Hello and welcome. Imagine traveling easily through space, or even backwards or forwards in time. Until now, these have only been possible through the special effects of Hollywood or science fiction books. One eminent scientist says they could be a reality in the coming decades. For those of you who are skeptical, just remember that scientists in the past thought that aeroplanes, lasers, televisions, and even the atomic bomb were beyond possibility. Don't forget, we take your calls on the show. Today we're asking, do you think time travel is possible in our lifetime? You can contact us through the details at the bottom of your screen. Joining me to discuss how developments in science will change our lives, making more things possible, is the renowned author Michio Kaku, who is Professor of Theoretical Physics at the University of New York. His most recent book is called Physics of the Impossible, and in that he argues that we need to expand our horizons on what might be possible in the future. Professor, good to have you with us.
Glad to be on the show.
Well, sir, you have some interesting categories on what is possible and what is impossible. Those three categories are very interesting, and I'd like you to take us through them first.
That's right. A class 1 impossibility is impossible today, but may be possible in the coming years to decades. And they include most of Hollywood's special effects like invisibility, teleportation, antimatter engine, starships. Class 2 impossibilities, however, require centuries to millennia, and that includes time travel and interdimensional travel. And Class 3 impossibilities are just downright impossible. Perpetual motion machines, for example, violate all the known laws of physics. So believe it or not, most of what you see on the silver screen is possible.
If I could challenge you, you said defy all the known laws of physics. So but potentially class 3 impossibilities could shift class.
That's right. We have two great theories of the universe. We have Einstein's theory of the very big, black holes and big bangs. And then we have the quantum theory of the very small, atomic physics, transistors, lasers. And these are the two foundations of modern physics. And perpetual motion machines violate these two theories. Now, that doesn't mean it's impossible totally. It just means it violates the quantum theory and Einstein's theory.
Now, it's interesting, you also have civilizations in three categories, from 1 to 3, and sadly, we figure at 0.
That's right. A type 1 civilization is planetary. They control the weather. They have cities on the ocean. They control volcanoes and earthquakes. Type 2 controls the power of a star, like the Federation of Planets in Star Trek. Captain Kirk belongs in a Type 2 civilization. Then we have Type 3, which is galactic, like the Empire of The Empire Strikes Back, or the Borg of Star Trek. However, we are Type 0. We're not even on the radar screen. Right. We get our energy from dead plants, oil and coal.
We're trying not to anymore, but we're still there, I'm afraid. Now, your book is titled Physics of the Impossible. Is there any comparison between what people, say, about 110 years ago or so said was impossible in terms of flight and so on, and what people nowadays are saying is impossible, such as time travel?
Well, take a look at something like invisibility. Just 2 years ago, I used to teach optics, and I used to tell my students that invisibility was impossible. And yet, 2 years ago, we did it. In fact, every physics textbook on the Earth is now wrong. At Duke University, at least in the microwave region, they showed that microwaves can go around an object, reform at the other end, just like water going around a boulder. Now, with visible light, it was done at Caltech on a microscopic scale. So in the coming years, Harry Potter, watch out. We're going to come very close to an invisibility cloak, just like in the movies.
We can show it actually as a graphic. People can see the way the cylinder. It's a cylinder actually. So poor Harry wouldn't have a cloak. He'd have to sit inside a cylinder, I guess.
That's right. There would be a cylinder enclosing Harry Potter, and light would bend around the cylinder, reform on the other side. So it's just as if he were disappeared, because light does not go through him, light goes around him, just like water around a boulder in a river.
We had an email that came in from Paul in London. I'd like to put this to you, sir. It says, what role will developments in science have on space travel? Do you think that the images that we see in science fiction movies, Star Trek and Star Wars, will become a reality in your lifetime, traveling through wormholes, laser guns and huge spaceships, transporting huge communities?
Well, one piece of science fiction may be possible in this century, and that's the space elevator. Imagine Jack and the Beanstalk, where Jack climbs up a beanstalk to heaven with carbon nanotube fibers strong enough to withstand the tension of a space elevator. You could go inside an elevator, hit the up button, and literally go into outer space. NASA has already given preliminary funding to investigate whether a space elevator could take our astronauts into near-Earth orbit, because right now it costs $10,000 to put a pound of anything into orbit. That's your weight in gold. That's how expensive space travel is. With a space elevator, we could open up the heavens to space exploration.
Now, Paul's email mentions Star Wars and Star Trek, and I wonder to what degree Hollywood and its wonderful special effects has changed our expectations of what is possible. I mean, we see everything looking so realistic in the movies. I wonder how we've adjusted mentally to the idea of all these things happening.
Well, some people may be a little bit disappointed when they look at the reality of where we are in physics, but I think the special effects really hypnotize young people. When I was a young kid, I used to watch the Flash Gordon series, and I was really inspired. Now, they had really cheesy special effects back in the 1930s. However, now with dazzling special effects, I think we're going to get the next generation of young people to be interested in science. Carl Sagan used to read the John Carter of Mars series, and he decided to become an astronomer as a consequence.
I'm familiar with that series as well. I go back a little bit in time too, and I'm wondering with, you mentioned what's possible and what's not possible over a period of time. What do you believe in your lifetime will be the thing that you really see materialize as something people might use?
Well, telepathy, believe it or not the kind of telepathy you get in a Las Vegas magic show, but real telepathy, I think, is coming very soon. At Brown University, just a few years ago, they took a stroke victim who was partially paralyzed, put a chip in his brain, connected it to a laptop, and in a few hours, like riding a bicycle, began to control the cursor on a laptop. This person can now answer email. He can do crossword puzzles, surf the web, and do anything that you can do on a computer, which of course is everything. And that's going to revolutionize the way we interface the brain with a computer. And also with brain scans, we can also see the thinking patterns of the brain and identify them. For example, when you tell a lie, you can actually see the fact that the brain uses up more energy to tell a lie than it does to tell the truth. So certain emotions, telling a lie, can be picked up now with a brain scan.
I've come across some very energetic people then. I wonder if we look across about 100 years then. Let's look down the road to about 100 years from now. What do you expect to materialize by that time?
Certain forms of teleportation should be available in that frame of time. 10 years ago, we teleported the first particle of light, literally zapped it across the room. The world's record now is about 100 miles. We can now teleport atoms, single beryllium atoms and cesium atoms. In a decade, we'll be teleporting molecules like water. After that, DNA, perhaps a virus, genes will be teleported. Now, however, there is a problem. The original has to be destroyed. So Captain Kirk has to dissolve in order for him to be zapped across the room. So true teleportation is many centuries away. But within 100 years, we will be teleporting on a regular basis simple objects.
Now, actually, I mean, if we just go down that line of teleportation, Professor, in theory, if that image that's being, or at least that thing that's being transported is being transported as information, once the computer has the information encoded, in theory, it could just replicate at the other end, which means you could end up with two, one at the origin and one at the final destination.
Well, that's what we originally thought. We thought we could take the information of A and transport it into B. But doing the mathematics, we found out that A really does have to dissolve, which raises a question. If you have a carbon copy of yourself and people saw you dissolve and die, then who is this imposter over here? Did your soul also transport across the room? It raises philosophical questions. If you die and you're resurrected someplace else, atom for atom, is that really you or not? What happened to your soul?
You also mentioned that many of these things that are being done right now in the laboratory, and I wonder what's the time span between something being achieved in the laboratory and it coming to everyday use? I mean, for example, at what point do people get a chance to say, pop into a teleporter and disappear to somewhere else?
Well, teleportation is still many, many decades away. And in order to teleport a human, that's perhaps centuries away. And that's what I call them class 2 impossibilities. Like, for example, time travel. Now, believe it or not, we physicists think that time travel may be consistent with the laws of physics. But you have to be able to manipulate the power of a star, a black hole, galactic energies before you can really open a gateway through space and time. But maybe our descendants have already mastered this technology. So one day, if somebody knocks on your door and claims to be your great-great-great-great-great-great-granddaughter, don't slam the door. Maybe it's true.
We were showing some pictures of black holes there for people to use as reference. Now, we'll be back with more questions in a moment for you, Professor. We have to take a short break. Don't go away. We're going to talk about how the impossible is becoming possible through science. Stay with us.